Hello children, good morning. Today we will discuss about electrolysis of acidified water using platinum electrode. In the previous video, I told you all about electrolysis of molten lead bromide. So let us start electrolysis of acidified water. So to perform the electrolysis of acidified water, we have to arrange apparatus as it is shown in the picture. Right? This particular apparatus is known as Halfmann voltameter. This is Halfmann voltameter. Halfmann's voltameter. Halfmann's voltameter. Halfmann's voltameter. Right? This Halfmann's voltameter is consist of two side tube. Okay, these two side tube are graduated tube, and in the middle, or you can say in the center, this particular tube is made to pour the acidified water. Okay, it is looks like a Thistle funnel. Okay, so with the help of this central tube, we have to pour acidified water, and the two partial or side tube, whatever is visible to you all in red and yellow color. Okay, it is used to collect oxygen and hydrogen gas after performing electrolysis. You can see here these two side tubes are connected with potential or battery. Okay, one is connected with positive terminal. This is called as anode, and another one is associated with negative terminal known as cathode. Okay, so here anode and cathode, if you talk about anode and cathode, it is consist of platinum foils. Okay, so here electrodes are consist of platinum foils which are inert, connected by copper wires to the two terminals of the battery. Okay, so here electrodes are of platinum foils and they are connected with battery with the help of copper wire. Right? So if we talk about electrolysis of water, so here apparatus used is Halfmann's voltameter. Apparatus used is Halfmann's voltameter apparatus. Halfmann's voltameter. Halfmann's voltameter, as I told you all, consists of two side tube and one central tube. Side tubes are used to collect the hydrogen and oxygen gas, and the central tube are used to pour acidified water into the apparatus. Okay. Electrode, if you talk about electrode in Halfmann's voltameter, or you can say for electrolysis of acidified water, electrodes are consist of platinum foil. Okay, and they are connected with battery with the help of copper wire. Right? Now come at another step. Electrode reaction. Here if you talk about electrode reaction, always remember pure water cannot undergo ionization. It cannot dissociate. That's why we used here acidified water. So here water is acidified with the help of dilute sulfuric acid. Always remember HCl and nitric acid cannot be used for the water to become acidified, because HCl and HNO3, you can say hydrochloric acid and nitric acids, both are volatile type of acid. That's why it is not used. They can convert into vapor. So whatever gas will be collected at respective electrode, that may be the mixture of HCl or nitric acid. That's why non-volatile acid, sulfuric acid, is used to make water acidified. Right? So if we talk about electrode reaction, acidified water first of all dissociates. So water dissociates into H plus and OH minus. Right? While sulfuric acid is also present. So sulfuric acid H2SO4 dissociates into 2H plus and SO4 2 minus. So what are ions are present? Let's see ions present into the apparatus now. Ions, we have three types of ion. We have H plus ion present into the electrolytic solution, OH minus ion, and SO4 2 minus ion. So we have three type of ion present into the solution, H plus, OH minus, SO4 2 minus, right? Now let's see what reaction takes place at cathode and anode. We all know, as we will supply the electric current, if we talk about procedure of electrolysis of acidified water, as we will supply electric current to the Halfmann voltameter, acidified water immediately dissociates, as I have given you all in this electrode reaction. As we will supply the electric current, or you can say as you will switch on the electric current, water will dissociate into H plus and OH minus, while sulfuric acid will dissociate into H plus and SO4 2 minus. So in this way, both water and sulfuric acid will dissociate when we will switch on the electric current. Okay, now after dissociation, we have ions into the electrolytic solution, and these ions will immediately start moving here and there toward the respective electrode. Positively charged ions will migrate toward negatively charged electrode, while negatively charged ions will migrate toward positively charged electrode. So we have H plus, OH minus, and SO4 2 minus. H plus, as it is a positively charged ion, will migrate toward cathode, because cathode is a negatively charged electrode, while SO4 minus and OH minus ion will migrate toward anode, because OH minus and SO4 2 minus is negatively charged ion, so very clear they will migrate toward the positively charged electrode, that is anode. So after migration, now ions will reach toward respective electrode. Okay, so now after reaching a respective electrode, a reaction will take place, right? So if we talk about reaction at cathode, let's see what reaction takes place at cathode. Reaction at cathode, right? So at cathode, H plus will migrate, because it is a positively charged ion. So H plus, we all know cathode is a type of electrode which is also known as electron reservoir, or you can say electron rich electrode, and here H plus is electron deficient ion. So immediately cathode will provide the electron to H plus, so that it can change into H neutral. This is called as primary reaction. Okay, we all know cathode is responsible for reduction, and here reduction process takes place. H plus gains electron to form H. This is a reduction. Reaction, and we all know cathode is responsible for reduction. So cathode is electron rich, it provided the electron to the H plus and it changed into the H neutral. We all know this is called as primary reaction. We all know H neutral cannot exist independently. That's why H will combine with another hydrogen to form H2 gas. This is called as secondary reaction. So here at cathode, hydrogen gas will be collected. At cathode, hydrogen gas will be collected. You can see here in Halfmann voltameter, okay, at cathode hydrogen gas is collected. Okay, in the Halfmann voltameter, it is visible to you all, I hope so, right? So after supplying of electric current, when the electrolyte H plus, H2 and sulfuric acid dissociate into respective ions, okay, then ions migrate toward the respective electrode. H plus migrated toward cathode, and at cathode they undergo a reduction to form H2 gas, and here at cathode hydrogen gas is collected. It is visible to you all, right? Now come at a reaction at anode. If we talk about reaction at anode, okay, so at anode, which type of ion will migrate? The ions which are negatively charged. So we have two ions which is negatively charged, OH minus and SO4 2 minus. In the previous classes, I told you all, if two same type of ions are present in the electrolytic solution, they compete in themselves. There is a competition between these ions. Okay, healthy competition takes place between the similar charge of ion into the electrolytic shell. So they will compete for the discharge. So here preferential discharge or selective discharge takes place. Okay, first of all we will follow the position of respective ions in the electrochemical series. So if we talk about OH minus and SO42 minus into the electrolytic series of electrochemical series of anions, OH minus is having bottom place and sulfate radical is having a top place into the electrochemical series of anion. We all know in the electrochemical series of anions, those ions which are having a lower position into the electrochemical series, they undergo a discharge. Preferentially they undergo discharge. So here position of OH minus is bottom into the electrochemical series, so OH minus will undergo discharge, not SO42 minus, because it is having the top position in the electrochemical series. So OH minus is electron rich ion. Okay, through the process of oxidation it will lose one electron to form OH. This is called as primary reaction, right? OH cannot exist independently, so OH will combine with another OH to form H2O and oxygen gas. H2O and oxygen gas, right? To make it balanced, we have to put stoichiometric coefficient 2, here also 2. It forms 2H2O and O2 gas will release, or you can say O2 gas will collect at anode. You can see in the Halfmann voltameter. Okay, here at anode oxygen gas is collected. At anode oxygen gas is collected, right? Okay. So this is the way how electrolysis of acidified water takes place. You always remember when your electrolysis of acidified water takes place, we collect oxygen, hydrogen and oxygen in the ratio of 2:1. Okay, so when your collection of hydrogen and oxygen takes place, we always collect hydrogen and oxygen in the ratio of 2:1. We collect 2 molecules of hydrogen and 1 molecule of oxygen. So 2S2 versus 1O2. Right? That's all for today. Thank you. I hope people understood how electrolysis of acidified water takes place. That's all. Thank you so much.